interested in, again, the primary point of today, the primary point is this idea of randomness, how to measure random behavior in events, like a coin flip, or pulling a card out of a deck, or eventually rolling a die. But the secondary topic that I really want to hit at today is this idea of finding an average behavior of a data set. So realize that's why I was laughing so hard when I was flipping my coin up here, was what I just flipped average. 9 flips before I saw, I got 8 tails in a row followed by heads. Is that average? Now, based on prior knowledge of how coins work, we're all laughing because it's not. But suppose no one had ever seen a coin flip before. Very young child, for example. You're trying to explain why coins are used to flip for sporting events, who takes the trash out. And you say, watch! Half the time you get heads, half the time you get tails. And you flip a coin, and it comes up tails 8 times. You're going to confuse the hell out of that kid, right? Because that anomaly is not normal behavior. So the best way to observe the usual behavior of a data set is to do what?
Run trials.
Run trials from the side of the room. Exactly right! Do a whole bunch of trials and see it work over time. And see it work over time. The grizzled old man voice. I love that. Run some more trials, man. So now let's do this. I think the flips have stopped. So we'll go around the room, starting with 2, going up to however I put myself in there, the 11. I also had a 3, if I remember correctly. I'm going to put that in there too. So what I want to do is, let's have you guys vote. I'll call out the number. You raise your hand and show me how many times that happened to you. Does that make sense? So 2. In other words, you flipped heads, tails, or tails, heads. Hands up high. Let me get some good counts. Let me get some good counts. Good. I don't need the calculator for what you guys are going to tell me. Oh, good.
Yeah, what if you get an edge?
Did you?
No.
But then 12.
He wants to see something.
See, now, Aaron, you actually bring up an exceptionally good point that I want to come back to, if that's okay.
Maybe not.
5,
It's just
8.
annoying today.
No, you're not annoying at all. You're actually being very pertinent with that comment, and I want to come back to it. You are, with the whole edge comment. You're being exceptionally pertinent, believe it or not. 7, 3. I got you guys over here. You're good. I'm sorry. 3, 6, 3, 6, 5, 6, 5. Right, you got 3? Okay, 5, 7. The cross tails are confusing me. 2. No, it's okay. 6, 7, 5, 6, 5, 4, 2, 8. That's 167. I'm going to put that up here. 167 of you.
What about
took it. What about yours?
No, 1. You can't get a 1.
You can't get a 1. Well, you can, but you haven't matched your faces. Then you haven't seen the face. Now, back over here. I want to. Before I cut the rest of the data, Aaron made a comment. It's one I hear often when we're flipping coins in class. What if it lands on its edge? To which I always ask, did you see that? To which the response is no. To which my response is, let's not talk about it then. Now, that might seem snippy, but it's not. It's the same argument I use when I hear that the head of Philip Morris said, smoking doesn't kill you. I've been smoking for 40 years, and I'm perfectly healthy. That is a data point that should have never, ever been aired anywhere. But yet, it got caught. It's been years since that statement was made. But it made mass media when it was made. What is that statement called? It's called an outlier. In 243, we learn how to measure them. What it is it's a super rare event. A super rare event, kind of like, I'm guessing, me flipping 9 flips until I saw, or 11, whatever it was, until I saw both sides. It's a rare event. Do you talk about that normal? No. The reason it upsets me so much is because how many times have you guys been watching television or something like that, and the commercial comes on for a weight loss program? I'm a 51-year-old grandmother of 3, and I've got the body of a 36-year-old. And in 8-point font below her picture, results not, well, or not typical. That's my favorite. Results may vary. Results may vary is actually a fairly accurate statement, as you're about to see right here. Results do vary, as a matter of fact. The problem is, results not typical? How dare you take someone who was the absolute best case scenario of your product and ignore the other 99.99% and use that as a marketing tool? Jared from Subway. I'm sorry. As an educator of statistics, it infuriates me when I see that crap in mass media. So Aaron, your point is well taken, because what you're doing is you're playing into that, which is great. But just be aware of that. It's amazing how it can happen. not just in mass media, those are the obvious cases, but in your own lives. Well, I heard this one time, and then you ask him, was it just one time? To which they'll say, what do you mean? To which you can respond, well, if it only happened one time, why are you talking about it? What happened the other 816 times that you experienced? You see what I'm getting at, friends? Don't focus on the outliers. I love that you brought it up because it is fitting. It is totally fitting. But realize how much that can affect you guys and your discussions around data and things like that. So thank you. I think it's great. All right, I'm going to update the graph. There's the updated graph. Let's go with 3 this time. So there's all kinds of ways this could have happened, right? It could have gone heads, heads, tails. Tails, tails, heads. I guess that's it, actually. 2 ways. Heads, heads, tails, or tails, tails, heads. All right, I better walk around the room again. 3s, nice and high. Here we go. 3, 2 is 5, 6, 7. Little on the edge. 9, 11, 12, 14, 16, 23, 25, 29, 30, 4, 36, 38, 41, 44, 51, 54, 56, 57, 58, 59, 65, 66. Love it. I want you guys to try to figure out if you could...
So that'd be 67.
Say that again.
67.
Was it 67? Okay.
Because you heard that point in it.
Oh, I was in there too. You're right. Thank you, sir. I need to change one thing real quick, friends. It's not automatically updating. Let's have it automatically update so I can stop doing F9.
What do you mean, Fred?
Fred, I called you Freds, actually. F-R-E-D. I'm calling y'all Fred today. 4s! 4, I'm calling y'all Freds today. 3, 4, 5, 6, 7, 8, 9, plus 4 is 13, 17, 18, 24, 25, 26, 27, 28, 29, 32, 33, 34, 35, 36, 37. Thank you, friends. Friends. 5! Look at this. Great plan, I love that. 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. 6. Couple of those. 1, 2, 3, 4, 5, 6, 7. Ooh, wrong button. Speaking of 7s. 1, 2, 3. 8s. 1, 2, 3. 9s. 10s. Aha, there they are. We got 3 10s. Very good, very good. 11, besides me. Anybody above 11? It could happen. It could happen. Okay, beautiful, friends. Here we go. Here we go. So my question for you is, on average, how many times will it take us to flip? Now, of course, the answer is right there. I've got Excel to calculate it for us. I've got Excel to calculate it. Your data says on average it would take 2.9 flips. 2.9 flips to see every face exactly one time. To see every face exactly one time. Which is really close to what?
3.
Which is what the exact number actually is. Which is what the exact number actually is 3. Now, you guys came damn close with 2.92. That's close enough to 3 for me to call it good. Let's make sure we remember how to calculate that. Okay, do you remember how we did the average in class last time? I want to go through it once more by hand, and then we're going to start using technology to crank it for us, because it does get annoying to do it by hand over time, especially with this one, because we have so many categories. Remember what kind of an average we called it? There it was again, Will, weighted average, thanks sir, a weighted average. And the reason is, it'd be very tempting, for example, to say, oh, well, you add 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 10 plus 11. Add all those together, and then divide by 9. Divide by 9. That seems easy, right? That's what an average is you add all the data up and divide by how many there are. And that's correct. To do an average, you add up how many data points you have and divide by how many you've got. So you add all the values up. But the problem is, if you go 2 plus 3 plus 4, blah, 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 how many 2s are you assuming you have? 1. In other words, I have to go 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. How many times? Kevin's looking for the right place. 167 times. And then I've got to go 3 plus 3 plus 3 plus 67 times. And then 4 plus 4, 37 times. And that's what I have to do. But we're not going to do that. That's what we used multiplication last time. We're going to do that via multiplication. Let's go to the sideboard over here. Weighted average. Good friend of yours.